Okay guys, this is the second review video for the Chapter 4 test. This was the extra worksheet that you got as some review. Remember, these reviews are not comprehensive to everything that's on the test, so make sure you go through your notes and your homework and your formative quizzes and your old quiz. Make sure you go through everything. Alright, so this first section we're trying to decide if these triangles can be proven congruent. Again, don't mark anything that you can't assume is congruent, and can't assume anything. You have to have a justification for everything. The only thing that we can mark congruent is this side because of the reflexive property. Then if you cover up one triangle, so let's just look at one triangle at a time, we have ASS, and we know that's a bad word. It's not a postulate, so we're not going to have enough information here to prove they're congruent. The second one, again reflexive. So now cover up one triangle and ASS again, but remember, if the A of ASS is a right angle, then we can use HL. Hypotenuse, leg. Hypotenuse congruent to hypotenuse, leg by reflexive congruent to leg, and we know the right triangles. So then we're going to write the congruence statement for these right triangles. Triangle EFH congruent to triangle GFH. Okay, number 3 here. Only mark things that you can justify. I can justify this angle congruent to this angle by the vertical angles theorem. Look at this marking here. That means they're telling us that these two lines are parallel. They tell you that for a reason. Always look for angles that could be congruent based on lines being parallel. So in this case, we have alternate interior angles. J congruent to L. If you mark J congruent to L, cover up one triangle, we've got a side between two angles. So that's ASA. I want to point out here that you could have marked the other two alternate interior angles congruent, I and M, and then you would have had a side not between your two angles, and that would have been AAS. So either one of those is fine, AAS or ASA. Either way, the triangle congruent statement would be triangle IKJ to triangle MLN. Nope, MKL. MKL. Good. All right. Number 4. Again, they mark these parallel to each other. This time we don't have alternate interior angles that are part of the two triangles. Consider this the transversal. These two are the parallel lines. We actually have corresponding angles this time. Those two are corresponding angles. So we're going to mark those a little more simply here. This is congruent to this. So again, cover up one triangle, and you have AAS, and the triangle congruence would be triangle POQ congruent to triangle ONR. Okay, list the 5 triangle congruence postulates or theorems that we learned. We have AAS, ASA, SSS, SAS, and HL. Remember, there's no AAA, AAA, and there's no ASS. If triangle CAB is congruent to FED, then C is congruent to F, and ABC is congruent to EDF. And AB is congruent to ED. These should have marks over them. And CB is congruent to FD. A triangle with all 3 sides congruent is called an equilateral triangle. And all 3 angles are equal to 60 degrees. Okay, if CAB is congruent to FED, then we have the correspondence. C is congruent to F, and A is congruent to E. A to E. And B then is congruent to D. Okay, so since we have all this correspondence, we know that measure of angle F equals 7y. And we know that the measure of angle F is going to match the measure of angle C, because these two correspond with each other. So you can write 7y equals 49. Solve that, you get y is 7. And if we do measure of angle E is 2x plus 1. E corresponds with A, we put the middle letter there. So 2x plus 1 equals 101. And when we solve that, we get x equals 50. Okay, on the back page, find x and y if these, again, this correspondence is going on here. So you know BC corresponds with QS. So these two are going to be equal to each other. And AC corresponds with RS. So these two are going to be equal to each other. So we solve these. 3x plus 10 equals 7x minus 2. And then we solve that. Subtract 3x from both sides, you get 4x equals 12, and x equals 3. This one is going to require factoring, so we have y squared minus 5y equals 2y minus 12. Remember, you have to get everything on one side and 0 on the other side. Subtract 2y from both sides. You're going to get y squared minus 7y. Add 12 to both sides. These are going to cancel to get you 0 on one side. Add 12 to both sides. So this is what we're going to factor. Y squared minus 7y plus 12. So we need something that multiplies to be positive 12 and adds to be negative 7. So that's going to be 3 and 4, both negative. So x equals, sorry, how did I switch to x's here? This is y. Y equals either 3 or 4. If you plug them back in, they both work. Actually, no, they don't. Plug 3 in here, we get 2 times 3, we get 6. Oh, that's right. We figured out earlier today that they both don't work, but we're just going to make sure on the test that they actually do work. So that was just practice with factoring. Sorry about that, but those numbers actually don't work out nicely there. Okay, find the length of BC and AC in number 7. So you're going to plug in BC. You're going to plug in 3 and get 7 times 3 minus 2, and that's 19. For AC, we would plug in y is 4. Yeah, it's going to be negative. Negative, say 4 squared is 16, minus 20 is negative 4, and 3 squared is 9, minus 15 is negative 6. So either way, they both turn out negative, which is bad answers, but that's the way it worked out. Okay, use triangle FDG at the right for 9 and 10. And we see that it's an isosceles triangle, so the angles across from those sides have to be congruent. So the measure of angle FDG, that's this one, is x squared plus 12, and the measure of angle FGD, that's this one, is 60 minus 2x. Since it's an isosceles triangle, those have to be equal to each other. Again, factoring, we've got to get everything on one side. So I'm going to subtract 60 from both sides. And I get x squared. 12 minus 60 is a negative 48. And then I'm going to add 2x to both sides. So we're going to factor 0 equals x squared plus 2x minus 48. Again, we are looking for two things that multiply to be negative 48 and add to be 2x. I'm thinking of 6 and 8. See if that works. A positive 8 and a negative 6 should do it. So x is going to be negative 8 or positive 6. If we plug in a negative 8 or a positive 6, they both work. So the measure of angle FDG, when we plug in negative 8 squared, we get 64 plus 12 is 76 degrees. When I plug in x is 6, I'm going to do 6 squared plus 12, and that's 36 plus 12, or 48. So both answers work. When you plug it in here, it should be the same thing. 60 minus 2 times negative 8, so that's 60 plus 16, and that's 76. And then if we plug in 6, we do 60 minus 2 times 6 is 60 minus 12 again, which is 48. So both should work there. Okay, draw the triangles described and find the value of x. In class we said you have to assume that the triangles are congruent. So F is the vertex angle of isosceles triangle FUN. So F is the vertex angle. That means it's the angle between the two congruent sides. And then in the other triangle, G is the vertex angle. Sorry. E is the vertex angle of GEO. E is the vertex angle of GEO. And the measure of angle G is 3x plus minus 6. So that's one of these angles. And the measure of angle F is 48 degrees. I'm going to draw this a little bit bigger here. F is the vertex angle, FUN, and E is the vertex angle, GEO. See, geometry is fun. That's what these two triangles are telling us. Okay, so E is the vertex angle. And now G is 3x minus 6, and F is 48. If we assume these triangles are congruent, that means this has to be 48 also, and it means this has to be 3x minus 6 also. And so we can write an equation, 3x minus 6 plus another 3x minus 6 plus 48. Those three angles add up to 180. And we would get 6x plus 36 equals 180, and 6x equals 144, and x equals 24. So this one, x equals 24. And write a congruent statement for the two triangles described in number 11. So triangle, if we start at the vertex angle, I'm going to do triangle FUN, congruent to triangle, start at the vertex angle again, EGO. Okay, so that's the end of that review sheet, but I just want to give you a couple of tips on the test. Make sure that you know, again, the vocabulary for isosceles triangles. This is the vertex angle. This is a leg. This is a leg. This is the base. So the two congruent sides are the legs and the non-congruent side is the base. And these two are called the base angles. Also know your parts of a right triangle. The two sides that form the L are the L legs. And the other side across from the right angle, is the hypotenuse. Okay, so remember these theorems that we learned and how to use them. Remember isosceles triangle theorem. Remember how to factor. Remember equilateral triangles. Each side is the same and each angle is 60 degrees. That's what you have to remember about that. Okay, make sure that you study your common terms sheet that's on the back of your first review sheet, where I give you that, that grid that says, here's the given. If, AD bisects FC or whatever, mark the diagram, AD bisects FC, and then give me the congruence or whatever statement you can make from it. Make sure you study that. You guys know what I mean. It's the very back of that stapled packet that I gave you. Remember, perpendicular means right angles. Okay? Three angles add up to one, of a triangle add up to 180. And I think that's good. Make sure that you practice, practice, practice. And good luck.